Okay, today's topic is on scientific notation, and it's used by scientists quite a bit to write out long numbers. Scientists have to do with long numbers when they're talking about distances in space, and then there's also long numbers when you're talking about really puny masses like masses of protons and electrons and things like that. So, for example, here you have the distance from the Earth to the Moon, and it's 384,000 kilometers. Let's say you have to write like a report on for a space project, and you have to use this number over and over and over again. It's kind of a pain to write out all these zeros. Well, scientific notation is a shortcut way to write numbers like this and longer ones with lots of zeros. Here's how you do it. You have to know your knowledge from the previous video on powers to the base 10. First thing you do is you're going to count the number of decimal spots needed to make the number greater than 1 but less than 10. So here's what I mean. This number here has an imaginary decimal right there at the end, as all numbers do, if it's not there to see. And what you want to do is you want to move the decimal and count the number of spots needed to make it, this number, greater than 1, but less than 10. So let's try that. So there's the decimal there, imaginary decimal there. And we count the number of spots needed to make it greater than 1, less than 10. 1, 2, 3, 4, 5. So put the decimal there, then we get 3.84. That is greater than 1 and it's less than 10. So we moved it 5 spots. That's like 5 zeros. So instead of writing out 5 zeros, what we can do is go 3.84 times 10 to the power 5. Because you remember before, 5 zeros is shown like that in exponential form. Now that is not a huge savings, because this is not a huge number, but this is a little tidier way of showing that number there. So this is scientific notation. And that's it. Next question. The distance from the Earth to the Sun, larger number, 149,600,000 kilometers. Same thing. You want to find the decimal, none that we can see, so it's at the end. Count the number of spots needed to make it greater than 1, less than 10. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. We move it there, the number becomes 1.496. You have to write out all the non-zero numbers. And how many spots do we move it again? I actually forgot. 1, 2, 3, 4, 5, 6, 7, 8. 8 spots we moved it. That's like 8 zeros. 8 zeros you can write out by going 10 to the power 8. And there's scientific notation. They call this, by the way, standard notation, and that's scientific notation. So the long way is called standard, and the new shortcut way is called scientific. All right. What about the speed of light? This time, we're going to take a number that's in scientific notation and convert it to standard notation. So 3.0 times 10 to the 8 meters in a second is how fast light travels. Well, let's see how we'd write this out. We're going to do the exact opposite of what we did up here. Here, we took the number and counted the number of decimal places to move it. And the number of decimal places was the exponent. Well, now we know what the exponent is. So if we're going to convert it to the other way, we're going to do the exact opposite. We're going to move the decimal 8 spots. Not to the left, but to the right. We know it's to the right because this is going to be a big number, and you want to go in the big number direction, which is to the right. So here's how I do this. I would just take the 3 and the decimals here, and then just move it 8 spots to the right. 1, 2, 3, 4, 5, 6, 7, 8. And there is where you put the decimal. And these little spots are kind of like egg carton holders, and you can put little eggs or zeros in each spot. It's as easy as that. So the number ends there. And so, it's best if you kind of got rid of that egg carton. Clean the thing up. That's not a decimal there, sorry. The decimal's at the end, but we don't need to show it when it's at the end. And put commas just to organize your place value here. That's 300 million meters per second. So light travels 300 million meters in 1 second. Pretty cool. Again, if you're worried about the science here behind all this stuff, I don't really care about that. It's more about the numbers and how to convert from scientific to standard or from standard to scientific. Those are for big numbers. But in science and life, you come across really, really small numbers, like the thickness of a cotton fiber. Here's a super small number. And the rule here is the same as above. You want to turn this number into something that's greater than 1 or equal to 1, less than 10. The decimal's right there. How many spots are we going to need? 1, 2, 3, 4, 5. That makes the number 1. And we're moving it 5 spots. 5 spots means 5 zeros, so it's 10 to the power 5. Now, because we're moving it in the opposite direction, in this will be 10 to the power negative 5. So what's the big difference here? Small numbers have negative exponents. Same thing here. When you have a small number, just always remember you're going to need a negative exponent, just like in the last lesson that you saw. So here, how many spots we move the decimal? 1, 2, 3, 4, 5, 6, 7. So it's 2 times 10 to the 7, but it's a puny little number, so it's 10 to the power negative 7. So small numbers, negative 7. Or if you want to think of it, if you're moving the decimal thing to the right, you'll have a negative exponent. What about the mass of a proton? The mass of a proton has been found to be this. So now we want to take it from scientific notation into standard notation. It was the same thing as before, but do realize with that negative exponent, that means we're going to have to move the decimal spot to the left many times. So what I'm going to do, and you can kind of see here, I'm going to move it 24 spots to the left. So let's make lots of room to the left. Let's write our 167 here. There's where the decimal is going to be, and we're going to move it 24 spots backwards. 1, 2, 3, 4, 5, 6, 7, 8. You know what? I should have left more room. This is going to be a puny number because protons are puny. So let's put the 167 over here. 167. Move it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. The decimal goes there. And this is one big, huge egg carton. I guess 2 dozen to be exact eggs, or zeros. We just fill them all in. Now, I think for this question you realize why scientific notation is so handy to have, because this is a lot of wasted time writing out all those zeros. I guess you should put a 0 out in front to make it 0.167. That's a pretty puny number, but thankfully scientific notation makes writing numbers like that unnecessary and get rid of the actual egg carton things to clean the number up. Oh, and don't forget the decimal, it goes right there. Okay, so scientific notation. Small numbers, negative exponents. Big numbers, positive exponents. Each case, you're trying to make the number greater than 1, but less than 10. And you're moving the decimal around and using your knowledge of powers of 10 to do that. Okay, if you could fill this table out, and where I give you the standard notation, give me the scientific notation, and where there's scientific notation, give me the standard notation. That one should be a lot of fun. That's it. Thanks, bye.